Hi girls, so today's video is about the auxiliary angle method. And the auxiliary angle method works on the sum and difference formulae for trig that we've been working on. And I'm just going to talk you through one example in this video, and then we'll tomorrow go through the other ones. But I want you to think about what the other ones might be and how they might work. So here's what the auxiliary angle method is basically. You've got some equation that looks like this. So you've got a sine of theta, and you got plus b cos of theta, for example. And what you can do, you can always do this, is you can relate this to something of the form r sine theta plus alpha. Okay. So if you imagine the right hand side, when I expand that double angle result, so remember sine has friends, so it goes, just the sine part will be sine theta cos alpha plus cos theta sine alpha, and then you'll get the r part as well. And what we're going to do is we're basically going to equate coefficients. So I'm just going to expand the right hand side here. So the right hand side, when I expand it, becomes r sine theta cos alpha plus r cos theta sine alpha. And try something new. Let's try the highlighter tool. So what I'm going to do is I'm going to equate coefficients on either side. So we've done this in the past, actually, back to writing, when you think about making two lines equal, like identically equal. So if you think about the line 2x plus 1 being the same as mx plus b, then you say that m and 2 must be the same, and b and 1 must be the same. That's a very simple example, but it basically says that the coefficients of each of the independent variables must be the same for an equality to be identically equal. Identically equal means, I don't think we've actually talked about this, identically equal means no matter what value of theta I put in, I want these two sides to be the same. And that's pretty obvious, right? That's what equals normally means to us. But mathematically, identically equal and equals imply slightly different things. Only slightly. So, back to our example with the highlighter, what that means is that I want a sine theta to be the same as r sine theta cos theta, and I want, there we go, I want r cos theta sine alpha to be the same as b cos theta. Okay? So I'm going to do with that on the next slide. So, first of all, I've got a sine theta equals r sine theta cos alpha. See you later, sine thetas. Divide both sides by sine theta. So then I get, therefore, a equals r cos alpha. And I could do exactly the same thing with the other one. So I get b cos theta equals r cos theta, sine alpha, divided by cos theta. Therefore, b equals r sine alpha. Oh, co-alpha, I think I meant cos. Okay, so now I've got two equations. Equation 1, equation 2. Now notice I've got cos and sine. Two equations with cos and sine. Can't do much, like I don't want to change the angle. I can't do cos of 90 minus alpha or anything like that. But I know something about cos and sine that always works, and that is that the sum of their squares is 1. So what I'm going to do, and let's try another new pen, really branching out today. So what I want to do is I want to try and square this one. Oh, pretty thick. Oh. Now I'm going to square this one as well. And then I'm going to add them together, because I'm then going to get cos squared theta, cos squared alpha I should say, and sine squared alpha, which when I add them together is 1. Okay, next slide. So therefore I get a squared plus b squared on the left hand side, and then on the right hand side I get r squared times, and if you'll forgive me just so I can fit it in, cos squared plus sine squared, cos squared alpha plus sine squared alpha, and that's just 1. So therefore I know that r is the square root of a squared plus b squared. That always happens. That always happens. Okay. You would normally be expected to do all this work in a question, but that always happens. So then I can go back to my previous slide, and if I look at equation 1 again, I should be able to calculate what A is. So the unsquared version. Sorry, alpha, not A. So I know that cos alpha is equal to A divided by the square root of A squared plus B squared. That should look like something we've dealt with before, because it is. Oh, orange. Draw a little triangle here. Alpha. There's A. A squared plus B squared. Whoops. So there's B. Okay. Hope you could hear me when I said that. I think I was speaking pretty soft. So I've got a right angle triangle, as always. And that's my angle with alpha in it. And then, if I just flack all the way back, there's my formula. All I needed to know was I needed to know R and I needed to know alpha. And then I had it expressed in the correct form. So how are we going to use this? So let's do an example. Let's say root 3 sine x minus cos x equals 0. And let's solve that equation. Now, that is not something I need this for, so I could add the cos x across, divide by cos x, get a tan, go from there, and just make sure we're careful about when we divide by cos x, it's not 0. But let's do it a slightly different way. So I'm going to re-express that. Now remember that r squared, oops, still on the eraser, sorry, that r squared equals root 3 squared plus 1 squared is 4. So therefore this thing is the same as 2 sine x, oops, I should have calculated this beforehand. So let's look back. So cos alpha is A on A squared plus B squared. So cos alpha is root 3 on 2. So that means that alpha must be 30. Is that right? Yeah, it is 30. And then the minus sign here, I want you to think about why it means that it's minus 30. Okay. And then that equals 0. And then you solve that the normal way. Okay, I'm going to stop there for today. So have a think about that for tonight, and then we'll go into a bit more detail tomorrow. Enjoy. Oh, I forgot to put a photo. Hold on. There you go. There's my dog sleeping. Get a good night's sleep. See you tomorrow.